Now we're going to look at each of the FRDS's main components to familiarize you with the system. The fire trigger is located on the flight stick. Depressing this trigger will cause the gate box doors to open when the power switch is on. The system is armed, and sufficient hydraulic pressure is present in the system. The pilot interface is used to display status to the pilot and allow adjustment of delivery settings. This panel is used to interact with the primary auto computer system. A manual system has been incorporated on AT802 serial numbers 66 and higher to provide better mission readiness. Using this panel, the pilot controls the backup manual computer and valves. The pilot can also open and close the doors, as well as manually operate the pump motor. This panel also has a manual salvo button that can be used to open the gate box doors, regardless of power or arm switch settings on the pilot interface. The automatic PLC is the main control computer that calculates the correct gate box door angle. The PLC also controls the hydraulic valves in real time based on input parameters from the pilot and environmental conditions such as G-forces, hopper quantity, and ground speed. Located in the same enclosure as the automatic PLC, the manual PLC serves as a backup to the automatic PLC. In the event the main PLC fails to properly function, this secondary computer allows for continued operation of the system with reduced accuracy. It also allows for manual control over basic functions such as opening and closing the doors and pump operation. The hydraulic pump, located just forward of the hopper on the pilot's left, supplies the hydraulic system with the high-pressure oil needed to open and close the fire gate doors. The nitrogen-filled hydraulic accumulator is slowly pressurized with fluid by the hydraulic pump at relatively low flow rates. During the release of retardant, the accumulator supplies the high oil flow rates required to open and close the gate box doors quickly for short periods during retardant delivery operations. The hydraulic manifold contains valves, sensors, and switches needed for controlling the position of the rotary actuator used to open and close the fire gate doors. This is the hydraulic actuator. It receives hydraulic fluid from the manifold and rotates the vanes as required to open or close the fire gate. A rotary position sensor or encoder is connected directly to the rotary actuator. This device measures and reports the angle of the actuator and gate box doors to the main control computer. The FRDS system uses a rotary sensor connected to a float assembly to monitor the amount of liquid present in the hopper. Buried deep inside the fuselage near the aircraft's loaded center of gravity is the FRDS's accelerometer. This device measures the acceleration of the aircraft. The control computer uses the actual vertical acceleration of the aircraft when calculating the angle of the gate box doors required to maintain constant retardant flow rate.